Okay. Thank you, Prabhat. Hello, everyone. A formal good evening to everyone. I've met most of you, if not all of you, either through a workshop session that we've had or through our 101 on essays that we've been doing. It's really a matter of privilege for me to be introducing Vinod Shankar, who defines himself as a strategist, a data and analytics leader, and an ex-health tech entrepreneur. Thank you so much for joining us, Vinod. And though the students know about you, the parents who are here know about you, this is just a little description of your profile. So Vinod has, as we said, is an entrepreneur and he's a digital transformation leader. And he has over 2 decades of experience in technology and consulting. I mean, this is where I have to pause because when you say over 2 decades of experience, Vinod, you don't look like you have 2 decades, which means that you're very young. When I say you don't look, means it doesn't seem like, you're like 20 years into the business. Specializes in building data and AI-driven products. He's the co-founder of VitaCloud. Now, VitaCloud is a digital health platform which he has orchestrated the acquisition by the Apollo Group and subsequently served as the product head of the telehealth business. His extensive career includes global leadership roles at KPMG Consulting and Capgemini. Thank you so much, Vinod, for agreeing to, deliver this lecture to us. And we are indeed very fortunate to have you in our midst. And I hand it over to you from here on.
Thank you, Prachi and Prabhat, for the kind words. It's great to be here. And just looking through this uh, list of young people that we have, one of the things that I've always believed in is being surrounded by young people. You guys bring so much energy, so many creative new ideas. It's sometimes very complementary to all the skills and the baggage that we carry as however old we are. So thanks, Prachi, for the compliment on how young I look. I wish I was as young in terms of my biological age. As a matter of fact, uh, in my startup that I founded when I was about 43 years old, uh, my co-founder was nearly half my age, and every day we learn from each other. It's very important about how crazy knowledge is and how the context of knowledge changes every single day. We'll cover some of that in this session. But what I want you to know is this is not sort of a seminary, and I'm not going to preach a bunch of things to you guys. This is not one of those COVID classes where the teacher is saying, "Put your camera on. I want to see you." It'll be nice for you guys to switch on your cameras because I wanted to make this interactive. You could be in your pajamas for all I care. Uh, Feel free to challenge me on my thoughts. Feel free to ask questions, and I'm going to throw open a lot of ideas at you and fire them right back at me, and then we make this very, very interactive. That's the objective, right? So when Prabhat suggested that I could do a session like this in a duration of an hour, at first I was first taken aback a little. How are we going to unpack so much that has happened over 50 years in a 1 hour session? And I started scratching my head. I started thinking about what can we cover and what can we not. And I've tried to put together these slides. I'm not a big slideware fan, but this is just to sort of, lay an outline of how I'd like my thoughts to be out there and overlay with your ideas, your thinking, and then we see how we can find some common grounds to have a very useful and productive discussion. So we'll talk about a bunch of things. I don't want this to be a very prescriptive session. I don't want this to be a classical lecture, as I said earlier. And definitely, I'm not going to be a prognosticator of the future, right? Because that's what AI, the way we hear about it in the media, is all sounding to be. There's a lot of fear mongering, there's a lot of hype, but I want to cut through all that clutter and make this more about, what are the opportunities? How do we brace ourselves for this brave new world? What do we have to do? What shouldn't we do? And stuff like that, right? So this is the agenda, right? We'll talk a little bit about all of this, and as with any session that I conduct on AI, my favorite uh, question, my favorite talking point, I like to hear from all the participants out there. What is your understanding of artificial intelligence? So feel free to unmute your mics, and I'm not looking for a definition, a textbook definition. So if you have keywords that you can think of, just throw them out there. If you're feeling a little shy or intimidated by my 20 years of experience, that doesn't mean anything. Trust me. Feel free to type it into chat, and I will read it there, and I will see if we have a meeting of the minds going on. So I'll pause now. You guys have any thoughts on what is artificial intelligence? Don't feel shy. I'm not a teacher. I told you before. There's no right
Yes, Sarah,
or wrong.
please.
Yeah,
Sarah, please go ahead.
go right
So I'm
ahead.
not really sure much about, like the definition as you said, but I do think a lot about the kind of ethical aspect of it. And I do think that, it's while it's called artificial intelligence, as far as I've seen, it's not exactly intelligent. It just looks at what people have found and what people have done and comes up with an answer that you're looking for. I'm thinking in this aspect, like I'm thinking in the respect of ChatGPT, that if you put in a prompt, it'll look at the internet, it'll look at what people have found and what people have written, and that's what it'll give you. So it's not exactly intelligent, it's just good at researching, I guess.
Okay, very good. I like those. The keywords I picked up from your answer were ethics, safety, risks. You're the person from Israel, right?
Yeah.
Sarah? Okay, okay. So incidentally, there's another one of your countrymen who goes by the name Mr. Harari, who talks a lot about ethics and safety. I'm sure you've heard about him. So great. Anyone else? I saw someone else put their hand up.
Yes. Good evening, sir. My name is Aryan.
No, sir. Just Vinod. Vinod is good. Doesn't matter. I told you I had a co-founder who was your age. So he used to call me Vinod Vin. He used to kick me every time he felt like. So no, sir, please.
Go
Uh,
ahead, Aryan.
yeah. So I think AI is something which is in its very early stage right now, and it is only reached around 20% of its potential or 30%. And there's so much more for it to do in the future. Right now, you can see that just in its beginning, it's doing around 70% of our chores for us in every scenario today. And being an AI engineer who's in second year only, I can see people who are learning so much about AI and creating their own chatbots, which tells me that there's so much more to discover on this topic. It's almost, yeah.
Okay, that's cool. You threw two numbers out there, and I find both of them, a little sort of massive in terms of what their impact can be on society and humanity as a whole. You said it has reached only 20% potential, right? And you said it is doing 70% of what we can do. Is that what you said?
No, I meant to say that you can see in my college, for example, no one codes anymore. Everyone puts it on ChatGPT and gets
No,
it.
it's fair. I mean, I'm not challenging what you said. 70% of what we do, by all means, I maybe more than that. So I just want to pause on that and reflect on that for a second. Imagine if it has barely scratched the surface to 20% and it is doing 70% of what we can do. Can you think about what it can do when it reaches 100% of its potential? We'll talk about that. Okay, so great. So ethics, safety, the potential, jobs, 20%. Okay, great. Anyone else? You can type it in chat
Yeah.
in the chat. I'm looking at that as well in case you.
So Soham wrote a paper on AI, right, Soham? But you have any
Okay,
opinion, views you
great.
want to share?
Fantastic. Okay, so if nobody else wants to add anything, I will just use some of the classical definitions of AI. And the reason I ask this question is because I don't think there's any right or wrong definition when it comes to this topic. Uh, it means many different things to many different people. So some people say, if you take human intelligence and try to simulate it into machines, that's AI. Others say that humans have a great many set of cognitive functions. So if computers start exhibiting that behavior, maybe that's artificial intelligence. Other people say take a very large set of data and do something to it, put it through some really clever technologies so that it can solve complex tasks. Maybe that is AI. Maybe the discovery of totally unknown things by finding patterns, trends, and all the information out there. Maybe that is AI. So like I said, there's no real binary definition or answer to this. There's a lot being written, said about it. I think it's always good to approach AI from all of these different angles so you get a complete view of it. There are some people who say, it means the redefinition of humans and machines interact with each other. What is our place in the world? Some people have gone on to the extent, I think Mr. Harari has said that, have gone on to the extent to say that it's a new life form, right? I mean, the aliens that we were always looking for, this is it. So there's a whole bunch of things out there. Given that, the next question I want to pose before you guys is, I'd love to hear your interpretation of AI from everyday examples, everyday things that you see, or you hear about, you read about. So again, I'll pause for a few seconds and I'll turn it over to you so you can tell me some examples that you have. I put some pictures over there. The first one, no guesses, it's self-driving cars or autonomous cars, right? That's a very classical example of extreme cutting-edge artificial intelligence. Do you guys have any examples that you want to share that you see on a day-to-day basis? Don't be afraid. Soham, where are you?
Yeah, Soham and Vasud and Sai Vidyut, come on.
Come on, guys. Like I said, don't be afraid. Don't be shy. Nobody is going to judge you on your knowledge of this because this is all very abstract. So throw it out there. Let's just debate, discuss, and figure out things together, right? So anyone?
I mean, I guess I could say something
Yeah,
also.
Vasud.
As the most common usage of AI, especially nowadays, in my opinion, is of course chatbots. So through information and everything, it can give you like a researching tool. But obviously, AI is also being used for a much longer period, in my opinion, in the field of self-driving cars. It's always been a dream, the future, to have self-driving cars. And there's also major developments for that nowadays. It doesn't necessarily have to be the car driving by itself, but just it being able to manage certain data that it receives from its environment and giving precautions accordingly is already a large thing. And also, I noticed there was a picture of e-commerce, and my opinion, AI is something that can make decisions based on its data that's given to it. So it doesn't have to be something extremely complex, in my opinion. Even something very simple as making a decision based on the data it has received is already a form of AI. And that's already being used for a longer period of time in a variety of websites. Also cookies from websites that you receive, that you accept, that no one really reads through. That's a form of data that you're willing to give, which then can be used for other websites where you can also use an AI can use it.
Very good, Vasud. Absolutely. All of those, like you said, AI is not new. There have been use cases, and we see some of these use cases without even realizing these are AI. And I will walk you through some of those things as we go along. All of what you mentioned are valid points. Anyone else wants to share any examples of?
Vinod Priyanshi has sent this on chat saying that when we watch some video on social media, videos related to that topic start coming on their own. That's an example of AI that she has cited.
Absolutely, it is. That is an example of AI because it's remembering the context. It's then synthesizing information, uh, trying to post ads to you. Yes, very much so. Any more? No. Okay, so we talked about e-commerce. I'm sure many of you have bought stuff from e-commerce websites. Have you seen on Amazon every time you go at the bottom of the page saying people who bought this also bought this, or if you bought this, you may also like these. So those product affinities and associations, that is a great example of AI. It uses affinity models to do that. In social media, so how often have you been spooked by somebody from 7 8 years ago, the person you've not been in touch with suddenly appearing as a potential connection, if whether it's LinkedIn or Facebook or any one of those sites. That's again using 6 degrees of separation to trying to find people from the past. So those are AI examples. Chatbot, like the one that you just mentioned. There are many chatbots that are great examples of artificial intelligence. uh, Day-to-day examples, again, Google Photos. Do you see how beautifully Google Photos recognizes people and then organizes your friends, your family members, and it different pictures, even ones in which they have a not a very clear image. It will pull up all of those and say, hey, this is that person, right? It makes those associations. That's a very good example of image recognition, computer vision. uh, there's plenty of examples in day-to-day life. Siri and Alexa, they use natural language processing. So yes, it has to a large extent become ubiquitous now. I mean, you can't escape AI. Wherever you go, you will find some implementation of AI, and we will talk through some of that in future slides as well. I think you mentioned Vasud, right? That AI is not new. You're absolutely right. I mean, I think the first time someone defined artificial intelligence as a terminology was some 80, 70, 80 years ago, long before even any of us, the seniors on this call, were around, right? I mean, can you imagine the first definition of a machine learning, that phrase that we use so much today, that came out in the 1940s and 50s? So this, I'm not sure you know this story about a computer scientist called Alan Turing. He's invented this great test in the 50s, mind you, 50s. Does anyone know what the Alan Turing test is for machines and intelligence?
I'm pretty sure it's a test to verify whether a machine is self-aware or not, or something. I'm not completely sure, but you ask it a variety of questions, and based on how it replies, you should then decide whether it's machine or human.
Yes, that is it, Vasud. I'll just briefly explain a little bit more. So there are three entities, uh, two humans and a machine, right? So one human poses a set of identical questions to the other human and the machine. And if the human who is posing the questions is able to make the distinction saying this is the machine answering, the machine has failed the test. If the human is not able to make the distinction between whether a human is answering or the machine is answering, that means the machine has passed. That means that machine has passed the Alan Turing test. And you would have heard a lot about that in recent times, because I've heard some chatter about ChatGPT or GPT 3.54 passing the Turing test. So some of those crazy things have been happening. So yes, we've heard of Deep Blue. Remember Deep Blue, the computer that beat the world chess champion? This was way back in the 80s. I think Prabhat, Prachi, and we would all have been little kids then, and we would have heard some of these stories about a computer beating the world champion. I think it was Kasparov, if I'm not mistaken, right? So that happened then, and then this shiny new toy that used to sort of navigate around your house. If you've seen those videos about the Roomba, this came out early 2000, and that was using a bunch of artificial intelligence to find its way, using lidar and all of those things to find its way around the house and clean the little crevices and nooks of individual rooms. So all of those things have been happening, right? Machine learning has been there, but why hasn't this picked up early on? Why didn't we find ourselves in a place, say the 60s, the 70s, or the 80s, that we find ourselves in today? What happened in 2023? I'll sort of unpack that a little bit for you guys. Before that, I just wanted to uh, show you this cluttered slide of how broadly artificial intelligence is classified today. So there are 5 or 6 disciplines, and you have natural language processing, you have speech recognition, you have vision, you have robotics, and you would have seen some examples of each of these in various aspects of your day-to-day lives. For examples, text to speech, speech to text, you would be seeing that in Siri and Alexa and all of those. Vision, as I told you a short while ago, Google Photos uses a lot of that. Robotics, you would have seen in those Amazon factories, the robots walking around with packages, so you can get rid of human labor and the risk of accidents, etc. So there's all of these things, but there is one particular discipline right here on the left: machine learning and deep learning. This has got the fancy of researchers and mathematicians, computer engineers over the last few years. So what is it? Before we start to declutter that, I want to take a moment to sort of touch upon what is the space and why is it important and what does it mean for the future. So machine learning, right? Anybody wants to hazard a guess on what machine learning could be? Okay, I won't spend much time. Basically, it's a sort of discipline in artificial intelligence which says that given an input A, right, you do a bunch of processing on it and you get to an output B. Okay, so given an input A, you get an output B, and then you do this in an iterative manner for many sets of this data, many sets of input A, you get an input B, output B. You do this long enough to have trained that algorithm. So then when you give it a new A, it is able to give you a very similar or an intelligent answer to what that output might be. One example is you train it on different types of dogs. There are so many different breeds of dogs, right? You train the machine learning model on a Shih Tzu, pug, a golden, and so on. And then you start showing it some other images of dogs that are in different angles, not very clear. And then the machine starts saying, hey, this is a dog. And if there is a golden retriever hidden away in a sort of a large group of human beings and other dogs, it'll pinpoint and tell you, hey, that's the golden retriever right there. So that's what machine learning is at a very, very high level. Given input A, it gives you an output B based on training. So basically what you've done is you have trained this model with structured, labeled data to arrive at an intelligent decision when you pose it some information that it has not seen before. So that is what machine learning is. And you basically, even self-driving cars, right? I mean, how do you train self-driving cars? They're on the road, and then you show it enough images of a human being crossing the road, like a street light, like no cattles, because I don't think cattles are meant to be on streets where self-driving cars will be there, but all sorts of obstacles and hazardous things, and then the car makes a decision about, hey, here's an obstacle, let me slam on the brakes. So you show it enough bridges, you show it enough signals, and it makes those decisions in real time. And would you guys believe if I told you that at some level we are all responsible? Prachi, you, Sarah, all of us are responsible, and we are training those models. We are training those cars to drive safely. Can someone tell me how? Yeah, I think someone's hands are twitching to unmute themselves and hazard a guess. Go right ahead, man. Don't worry. You could be wrong. I don't care. How are we training? Sitting right in front of our machines, how are we training these models? How are we training cars to drive more carefully?
Data sets, ma'am.
Data sets? Can you elaborate, Aryan?
For example, data sets not only in terms of tables and all that, tables, it maybe in terms of audio clips, visual clips, photos, which show driving behavior or how people usually drive versus how traffic moves, and maps to show where you should take a turn. Basically, it learns from data, right? That's what the whole concept of machine learning is.
It learns from data. You're right. And maybe some of that data you would have generated, maybe some of them you would not have. That may be a secondary contributing factor, Aryan. But I'll tell you a direct way in which, has someone posted something on chat that I'm not looking at? Anay, you're saying giving information based on previous accidents to teach these models to avoid those situations. If you were involved in an accident, absolutely, Anay. I hope you've not been. No, but that's a good point. That's not what I had in mind. So tell me something. When you guys are browsing the internet, right? Have you encountered this captcha things? Identify all the bridges on this grid. Have you seen that? Yes.
Yeah.
Yeah.
Yep.
Identify all the dogs, cats. Identify all the zebra crossings, all the signal posts. So when you identify that, what you're essentially doing is you are labeling those data sets. Okay, you are a labeler. You are making that label, and that label will be used by Google or whoever is using those captchas to train their cars to recognize these obstacles in real time. So the next time you do a captcha with the bridges, don't think, what the hell does this mean? Because I've had so many people ask me, what is this captcha? Who uses it? What kind of a riddle is this? There is a method to the madness, right? So these guys are very intelligent. They don't want to waste anything that they can't find value out of. So that's what those captchas means. That is an example of machine learning. Uh, so machine learning has been there, as you saw in the previous slide, right? I mean, these guys have been around for such a long time in the history of AI. There is another branch called deep learning, and within deep learning, something called neural networks. Okay, this is the catalyst that has completely transformed AI, and the Chat GPT stuff that someone mentioned before the call. This is what is driving that sort of complete transformation, disruption, and inflection in how we can compute things, how we perform day-to-day tasks, etc. So, why is it called a neural network? Anyone wants to hazard a guess?
Connected
Is that
to
a part of the brain?
neurons.
Sorry. Yeah, go ahead. I think there were two people. Take turns. Prachi, I think you were saying something. Go right ahead.
I said the neurons in the brain, the connections that they make
Neurons in the
and
brain.
process information then.
Absolutely, the neurons in the brain. So that's how the human brain works, right? There are these billions of little neurons in our brain that are interconnected through what they call synapses, the space between these neurons, and there are neurotransmitters that, I mean, let's not even go there. I don't think most people even get it. Even the best researchers in the world have not been able to crack entirely and decode how it works. But uh, researchers said, right, human intelligence is based on neurons. What if we modeled our AI on a similar principle and had, a large enough algorithm with these millions and potentially billions and trillions of neurons that could be used to arrive at the right prediction. So just like you have machine learning, classical machine learning, in which you use a label to train something to make a decision, in neural networks you don't necessarily train it. The network figures things out itself for the large part, right? There are deviations, of course. We'll come to some of that, but there are deviations. So if you look at this little, interconnected thing on the bottom right of the screen that you're looking at, that is how a neural network looks like. So there's an input layer, there are hidden layers where information is stored, the information that you use to train the network is stored, and then there is an output layer. So basically, you simple things like, you want to make a decision, and there are four variables to that decision. You want to decide whether you want to eat pizza tonight. So you look at things. You might look at things that would go along the lines of, am I hungry tonight? Uh, do I have enough money for buying a pizza? Uh, do I have some friends that I could call over for a pizza party? So there are 3 or 4 questions that come into your mind. That's how you think, right? So a neural network uses those questions as inputs, and those inputs are then transmitted through this network, and weightages are accorded to each one of those questions. Are you hungry tonight? Maybe I'll give that a higher weightage. Am I concerned about my health and as a result shouldn't be ordering a pizza? Hey, who cares? I don't eat pizzas every day, so I'll put a very low weightage to that. So for each one of those questions, I put the weightages, I compute a response from those individual nodes, which are called neurons in a neural network as well. And then I apply some bias to it and I get a response. So my response will look like one, yeah, go ahead, go right ahead, order a pizza. Or it may say, I may get a response that's a binary zero, and it'll say, don't order a pizza based on the weightages, based on my priorities. So a neural network works in along similar principles. Okay, so human brain full of neurons, a neural network full of these neurons into which the parameters are loaded. So then, the obvious question that people ask is, if this thing was all figured out, in the 60s, 70s, and 80s, why haven't we had these up and running 30 years ago? Why is it taking such a long time for us to get to these models and these artificial intelligence systems? So again, I want to throw it back at you guys. Do you have any thoughts on what were the barriers? Why didn't we get to artificial neural networks so far?
Yeah, I have an idea.
Yeah, go ahead, sir.
Maybe because the brain is like a complex place, and like they already didn't know how the brain works, so it was hard to implement that into something else.
But remember, I told you the scientists had figured out the structure of the brain and consequently how a neural network should be modeled. So they had figured this part out in the 70s and 80s, right? It's just that they couldn't implement it. And my question is why? So your thinking is right. If you want to continue on that thinking, meanwhile there's someone else. Uh,
Yeah. So I think I'm also kind of add up on Sarah's opinion.
yeah, go ahead.
I think a large problem was the amount of data that was necessary. Like the human brain is an extremely highly complex computer, you could even call it,
Yeah.
that runs a universal amount of process at the same time, which we are not really properly aware of, but it still does. And if you want to simulate that on a computer, theoretically, sure, I think we already have figured it out to some degree. But if you want to practically implement it, I think the amount of data and processing that is necessary to then make the short time decisions as a human brain does is a bit too complex for the technology we have today.
Fantastic, Vasu. Absolutely. Anyone wants to add on to that before I dig a little deeper into that theory and framework? No? Okay. So great answers from both of you. So essentially, I want to talk about this law of exponentiality. How things grow, and in an exponential growth, how they grow slowly at the beginning, gradually, and suddenly they turn like that and they grow exponentially. Okay, anyone heard of Moore's law here? It's a very important concept to be able to grasp this whole framework of exponentiality and artificial intelligence. I'll tell you what it is. Somewhere in the 60s, okay, this scientist called Mr. Moore, I forget his first name, he introduced this concept, and he said that every 2 years the number of transistors on a computer chip would double. Okay, so essentially what that means is, if you're taking your reference point in sometime in 1965, and it had 100,000 transistors then, so in 2 years it would become 200,000, right? Next 2 years it will become double of that, so that doubling continues. So the number of transistors on a chip will double every 2 years. Now let's pause this and put it into perspective. Okay, it's very important for all of you as youngsters to appreciate this concept of exponentiality, because it's not just a tool that will be used in computer systems, but in daily life, and I'll tell you how. So if you have a piece of paper, just a very simple A4 paper, okay? If I start folding it, right? I start folding it as such, right? How many times did I fold it now?
Once.
One.
I folded it once. Now I folded it twice. Okay, so now this paper is folded twice, and I keep doing this. At some point, my physical strength will not let me fold it further. Okay, but theoretically, if I kept folding this piece of paper, by the time I'm at 7 folds, I would be, I don't have a book here with me, but I would be at the thickness of a book. Okay, 7 folds, thickness of a book. By the time I'm at 12 folds, 1, 2, 12 folds, I will be at the height of a stool. Okay, a stool. By the time I'm at 14 folds, I will be at the height of a human being, an average height human being. So from 2 folds to 14 folds, I'm at the height of a human being. Can you grasp that? Can you imagine that? Right? By the time I'm at 17 folds, 14 to 17, I'm at the height of a 2-story building. Okay, so that is, now we are starting to get into the exponential growth phase. Remember the first fold, second fold, third fold, that was the smooth part of the curve. Now by the time I'm at 17 folds, I'm the height of a 2-story building. And by the time I'm at 50 folds, 50, okay, it is the distance between me and the sun. That is exponentiality. I mean, if you're able to grasp that concept, you'll be able to understand Moore's law and all of this AI related compute processing, all of that very easily. So from 1 fold, right, just this, if I started folding this 50 times, I may not be able to do it theoretically, mind you, practically, but at 50 folds, I will be reaching the sun. This will stack up to the sun. That's one example. Another example that many of your parents would have told you, that the power of compounding in interest, right? I mean, if you keep compounding money, you reach a very large sum. You guys would have watched Who Wants to Be a Millionaire or the Indian equivalent Kaun Banega Crorepati. Have you seen, they start with like, I don't know what, $100, then $200, like $400, and before you know it, he's waging for a crore or $1 million. That's exactly how it happens. So 1 rupee, I've written this down because I don't remember it off the top of my head. 1 rupee doubled every day for 15 days, right? So day 1, 1 rupee, day 2, 2 rupees. On the 15th day, that would be 15,000 rupees. Okay. So starting with 1 rupee, on the 15th day, I'm at 15,000 rupees. On the 25th day, I'm at about 1.5 crores. Okay. 1.5 crores. 25th day. And 30th day, just 5 days later, I'm at 50 crores. So I just wanted to throw that as a perspective for you guys. That is what the exponentiality in computing means. And that is exactly what has happened. When we were young, Prabhat and I, we used to work on, Pentium chips. And Pentium chips had transistors that, would be, I think, like a few million transistors on those Pentium chips. And those were state of the art at that time. And you guys would have worked on Intel i7 i9 and all that. I forget what those what the number of transistors on those were, but they were like maybe a billion or something like that. But modern day computing really amplifies this. Some clever guys said there is something called a GPU, not a CPU, like a computer processing unit. There's something called a GPU. Anybody know what a GPU is? Yeah, go ahead.
I think the graphics processing unit.
The graphic processing unit. So basically, all computers that let you play those fast games with high fidelity animation, they use GPUs. GPUs are very expensive. They start at a few $1,000s and go right to $30,000-$40,000, right? So somebody realized if we started using those GPUs to train these AI models, that would be just transformative. And right here, over here, where I'm pointing my cursor, was when NVIDIA, the chip making company, they realized that these chips can really power artificial intelligence, and these neurons that you could never simulate in a physical digital setup. If you use those NVIDIA chips, you can start simulating a human brain. Not one chip, but hundreds of thousands of those GPUs. Okay, so that's what this first graph is referring to. The second graph is referring to the growth of something else. Anyone wants to hazard a guess what this might be? Someone talked to this before. I think one of you referred to something growing exponentially over the years.
I think that ZB at the top is referring to zettabytes, if I'm not mistaken. Is it?
Zettabytes. So what might that be? What has grown? What will grow to 175 zettabytes in 2025?
I presume the size of data.
Yes, that's the size of data in the universe. Right? All data that human beings have generated so far. I don't even know how many zeros that has. I think 10 to the power 21 or something like that. So if you work backwards, 1 zettabyte, I think is 1000 exabytes. 1 exabyte is 1000 petabytes. 1 petabyte is 1000 terabytes. And we are at the GB level in terms of how much data we play with on a daily basis. So that's a lot of information. So when you combine this data explosion and this availability of compute, and you overlay this old concept of a neural network, you get what is called generative AI, or the large language model. And these are the models that, modern day artificial intelligence, you would be hearing about GPT-3, GPT-4, Llama, Claude, do all of these things. This is the way they go about it. Now, obviously with lots of shades of improvement over previous versions. For example, even if you take neural networks, traditional ones used to be called, I won't get into the details of that, right? I mean, this is not a research class, but there used to be recurrent neural networks, convolutional neural networks. So Google did this very interesting transform neural networks, right? And they came up with this transformer neural networks sometime 10 years ago, and they wrote a paper on that, and they left that paper there. And this bunch of smart guys called Elon Musk and Sam Altman, all these individuals picked up that paper. They said, why don't we put this into practice? They used that same transformer architecture of a neural network that Google had written the paper on, and they worked on it from, I think, 2017 or so, 2016, 17. They've been working on that for the last 6-7 years, and they found this mind-blowing responses and outcomes as a result of this sort of an architecture and a framework. And that is what you and I are playing with in 2023. They've seen early versions of this over the last 2-3 years. There are many interesting stories on how they presented it to Bill Gates, and he fell off his chair when he first saw some of these early examples of how these models were behaving. But this is the present day large language model. This is how it came to be. Okay, and where we stand now. Prabhat, how are we doing on time? I'm sorry, sometimes I get too involved in this and I lose track of the time. Do we have a hard stop at 7 o'clock or
No,
want me to...
I think we can take another 15 minutes after 7, so not a problem.
Okay.
I think this is not an easy subject. It's a very, very relevant subject.
Okay.
Probably, in my view, this is the most relevant subject to every child or every student. So I think let's make the most of it. So go ahead.
Great, wonderful. So I'm also happy it's interactive. You guys are participating, although I would like to hear some more voices, some more thoughts from other participants in the room. So this is where we stand today. In 2023, you have all these large language models, and you'll only see the usual suspects: Google, Facebook with their Llama model. You'll see Claude, that is backed from a company called Anthropic, that is backed by Amazon. You'll see OpenAI backed by Microsoft. Usual suspects. So essentially, they're training these models using a ton of compute, and they cost a lot of money. So these are organizations with very deep pockets, and they cost hundreds of millions of dollars to train these large language models. And early versions of the large language models were mainly text based. So if you've played with Chat GPT, it has attained what is the mastery of language, right? I mean, it's beautiful poetry and stuff like that it's able to do for you, and I'm sure you guys will also relate to some of the essays that it can write. But later versions of these large language models were trained on not just text, but images, videos, audios, code, right? So a lot of different things. So right now where we stand is there is, a large chunk of the internet that has been taken and put into these neural networks. Just to put it in perspective, the first version of GPT had 110 million parameters when it was trained. I think Chat GPT 3.5 had 175 billion with a B parameters that it was trained on. GPT-4, I don't know the exact number, but I think it's over 1.5 trillion. So we are now slowly getting into that threshold where these machines are even larger than the capacity of the human brain. And which is why you are now starting to see these things do some pretty damn impressive things, right? We'll look at some of those. So basically what the researchers have realized is the magic, there's no magic wand to this. You basically, the human brain has 86 billion neurons with 100 trillion connections between those neurons. So anything that will get you close to that or overtake that, you are in the realm of intelligence that is better than humans, the average human being, right? And that is what these researchers have realized. So they're throwing in more data, they're throwing in more compute, and that very intelligent neural network is figuring it out. And that's a funny thing. You ask the best researcher in the world, Ilya Sutskever, any of these guys, right? A lot about why the neural network behaves the way it does is still not known. All you know is it is self-adjusting, biases, the weights, and all of those things. It takes care of itself. As a matter of fact, once a model is trained, I saw this great example. I think Andrei Karpathy had this very good podcast in which he said that the Llama 2 model from Facebook, it was trained on 70 billion parameters, but when that was output and ready to run on a laptop like the one I'm having right now, it just has 500 lines of code. Only 500 lines of code, and it has a parameters file which is about 160, 170 gigs. So that's pretty mind-blowing in terms of how a compressed zip file and 500 lines of code is all you need to, once you've trained the model, run these and get your predictions, your deductions based off, right? So that's where we are. I've put a point over there, Sarah, you will connect with that point, concerns over safety, risks, ethics, right? So all of these things are being talked about now. Policies are being formulated. People are worried, people are excited, there's fear mongering, there's hype. That's the world we live on in 2023. And what is the impact? The adoption of these models have risen, and maybe if you're not following enough in public knowledge and the world outside you, it's very easy to miss some of these things. But a lot has been happening over the last 1 year, and all these things have been happening over 1 year. So keep in mind, we are I think someone just unmuted there. Okay, so we are at that exponential part, right, of where the thing is now starting to reach escape velocity and vertical takeoff, right? So imagine what's going to happen. So now, if you're following this space, there is one new update that comes out every single day. Yesterday, last week, Google Gemini came up with their model, and they said we've broken the thresholds of the MMLU test. I'll talk about that in a little bit. I reach out to my friends who were programmers once upon a time, and they tell me that their teams now, right, are embracing tools like Copilot, and their work in actually coding has come down by 40 to 50%. These tools are improving productivity and efficiency by several factors, and that is only going to increase as we move forward. There have been workforce shifts that have been seen, right? I mean, content, teams, large content teams of people who used to generate these content by doing research, logging it out. Now you just need to click and you get your content generated for you right there. Someone verifies it, it's good to go. So some of these things you are going to amplify many times over, and that's what we're going to see in the next few years. I just wanted to talk a little bit about, whilst there is a lot of hype on the generative AI aspect, the neural network aspect of of this whole tool, uh, there's a lot of economic value still in classical AI, and this is a very important message for you guys, because if you're starting to now dig into some of these things and look at it either from a standpoint of how do I get directly involved, how do I get into the space so I can start building some of these things on my own, or how can you be a consumer to some of these things, it's good for you to know that the green circle, the bubble, that is the classical machine learning, right? Supervised and labeled data. Remember that I was talking about the superset of deep learning and neural networks. So that green one is still where tremendous amount of economic value is. Generative AI today is that smaller red dot that you see in this, and where it'll be in 3 years is there. And in 3 years, supervised learning or classical machine learning will be here. So don't think of AI as only chat GPT. That's the message that you have to carry away. There's a lot of other things happening in AI, and keep your eyes and ears open for all of those things. I won't talk much to that, uh, but I often get asked this question. Suppose I'm a student, or I've just finished my schooling, and I want to look at how do I dive into this space, how do I start figuring out things. And I've generally used 3 of these sweet spots that people can enter into. But before that, this what you see on the left is where the AI stack largely resides, and this is mainly the generative AI stack. So there's hardware, there's the cloud platforms, there are these models, these LLMs that I was talking about, and then there are the apps on top. A lot of innovation that developers are doing are at the app level, because as I said earlier, the hardware and the models, they're all very capital intensive. So a lot of things are happening in this space of app development, right? So if you look at things that you guys probably are already doing is you have GPT, Copilot, all of these things that you're using to figure things out better. I've seen a lot of content innovators create brand new and very interesting products, and these are products that you know sort of defy the traditional definition of a product. But a great example of a person somewhere in Bangalore, I don't know where, but they realize there are so many of these mythological stories that exist in India, and so many cultural aspects about religious stories, mythological, and so they started using some of these tools like Midjourney and Chat GPT, and they started creating comics out of those. Right. So all basically you need to do is give it prompts, say, here's a little storyline. Can you create a comic for me? And it'll create a brand new comic. So they've started an entire business based on this. So pick out all these folk tales and mythologies, and then put it into these tools, and you start getting comic books entirely. And they're starting to sell this. They're making money out of that. There are people who've written entirely new novels based on some of these tools. There are people who've created small video clips based on some of these tools. So a lot of innovation is happening in that content space. And the third one is people are building end-to-end apps. So for those inclined towards software engineering and app development, there are a lot of people doing that as well. So there are multiple entry points into this. A great way, if you ask me, is for someone who's not initiated much into this, is to start by just consuming it. Download 2-3 tools like ChatGPT, Midjourney, Stability Diffusion, some of those tools like Copilot for coding, and start playing with it. Get your hands dirty. You will get a good sense of what it is, and then you can decide what you want to choose and take forward, right? So this is an important one for people who are going to graduate in the next 4-5 years. So I'm a parent of a 9th grader myself, and I often think about by the time my daughter is in 12th, what should she be choosing to do? And I don't have the answer to that question, right? I mean, there's no black and white, but the screen will give you a fair sense of where we are and what the future might look like. Let me walk you through this. So basically, this there are 3 levels: artificial intelligence, artificial general intelligence, and super intelligence. Okay, and basically where we are today is at this where I've indicated this mark saying today, and at I've also placed this little chart which is called an MMLU benchmark. It's a massive multitask language benchmark, which basically says at 89%, a set of questions can be answered by an expert human being, right? 89% is a human being's level of expertise. And so far, GPT-4 was at 86.4%, a shade below that. And when Google Gemini came out last week, again, remember the exponentiality aspect, things are happening very fast. They said their model is at 90%. So there are 50 different subject areas in this MMLU benchmark, and Google said that most of those, their tool is able to answer much better than a human being, an expert human being. So that can be in medicine, it can be in software development, it can be in teaching, healthcare, many different areas. So that's where we stand, and that's where we are today, right? And there's this term called artificial general intelligence, or AGI, and a lot of the researchers and some of the tech execs, I've heard them define this in various ways. For example, Elon Musk says AGI is smarter than the smartest human. Okay. Sam Altman says when it starts reaching a stage where the tool can develop its own science, or start developing new science of its own, that's when we are at AGI. So there are many different definitions, but essentially, when we're at a stage where you can hire a co-worker who's not a real human being and a digital, like a computer, that's when we've reached AGI. And some of the numbers, some of the time frames that I'm seeing for that are pretty stunning. I hear OpenAI guys say that by the turn of the decade, before 2030, we will reach this stage of AGI. Elon Musk says next 3 years. There was some chatter in the last 2 weeks. I don't know if you guys followed that whole drama of Sam Altman getting fired by the board, and you guys saw that, right? So many people say that they were very close to one of those disciplines that will get you to AGI, where basically you figure out math and algorithmic reasoning. So once you crack math and algorithmic reasoning, you are at the human level, right? So it's not very far, which is why I've placed today in AGI. AGI is coming. It'll be here in the next few years. And then you have super intelligence that is like much higher than just human beings. These are like I don't want to get into the worst case scenario of Skynet type definitions, but these are tools and technologies that can create operate at much higher levels of intelligence. So we'll park that for another day. It's a very debatable topic as well. Okay. So any questions on this slide? On any thoughts, any ideas you have? I know I'm rushing a little bit just to sort of align with the overall time frame. No? Okay. So my last slide, right? So given all of this, given where we stand in terms of the evolution of AI, where we are today, where we think we will be tomorrow, I've had many people, including my daughter, ask me, how should I prepare myself, right? Should I take up software engineering or computer science by the time I finish my 12th grade? Should I do something that will not no longer exist as an occupation? And the answers are not straightforward. But to sort of bring the thought clarity on this topic, I tend to divide my thought process into these two aspects. What are the inevitables and what are the immutables? So you guys probably already know, inevitables are things that you can't avoid, right? They will be here. It's just a matter of when they're coming. And immutables are the ones that they don't change. They evolve to some extent in the way they're delivered, the way they're structured, but the basic tenet will not change. So what are the inevitables, right? So there's going to be an AI in all spheres of life, right? There's going to be AI tutors, there's going to be AI physicians, there's going to be AI artists doing a lot of things that we do as human beings today. And we can't push back on that. There's also going to be an AI co-worker very soon. We don't know whether it's going to be a robot or still digital intelligence, like a computer doing such things, but early signs of this, I was talking about Copilot that helps in coding. So an AI co-worker is an inevitable. Robots, bots. So all it needs is you take this neural net, this technology, generative AI, and then you put it into the robot. And this marriage is what will create, a very intelligent bot, a being of that can go ahead and do a bunch of things that all of us can do. There's bound to be workforce shifts. There's going to be jobs that are going to change. There's a lot of fear that people say, Lord, there's going to be a job destruction at large scale, and people are going to be jobless. It's going to be a post-jobs world where people are not going to know what to do. I think that's all overblown. If you look at the type of jobs that exist today, I think 70 to 80% of those jobs didn't exist back when some of those early machine learning principles were defined. So jobs change, industries change, and I think that is going to happen again over the next few years as artificial intelligence expands as it progresses. So again, revisiting careers, that's going to be inevitable. The only thing that we need to ask ourselves is, if I had planned to become an application coder, maybe it's a good time to reorient ourselves and think of, if computers is what I like doing, maybe application coding is not the thing that I should be focusing too much on. Maybe I should be looking at applied research. Maybe I should be looking at product design development to a large extent. Maybe I should be looking at expert coding, because obviously everybody is going to be a coder with such tools. So if you want to differentiate yourself in the workplace, coding is not going to be the differentiator, because these tools are going to be available to everybody. But there's going to be high-end coding available, and one of the principles that most companies are operating on, the guys that are creating this, is of having a human in the loop. In every one of these aspects, there's going to be a human in the loop. So there's never going to be, hopefully 100% digital robots coding. There's going to be humans involved who are going to help with the coding and all those aspects of software engineering. So what are the things that you should focus on? I think those immutables are very important. My daughter asks me often, should I continue studying math and science? They're going to be redundant. I tell her, no, it's not going to be redundant. That's immutable. That's invariable. Those principles of math that exist today actually feed a lot of the algorithms. A lot of those neural networks are all math-based problems that researchers are trying to crack and marry with some of these concepts. So I think you should continue keeping your focus on these primary subjects, whether it is science, STEM, whether it is humanities, whether it is arts. If that is an area of interest to you, I think you should double down on that, if anything, not withdraw from it, right? In addition to that, I think what students should do is, you should look at, how do I be more creative in both problem framing as well as problem solving? How can I bring more of a human-centric design approach in all the things that I do? Even if I'm just creating a very simple slide deck to present in school, how do I make it more creative? How do I make it more design-centered? How do I bring more empathy and compassion into my life? How do I network? How do I build these connections with other human beings? Because when there's going to be a lot of machines, we are going to yearn for good old times where there was human to human level of connections, and that level of trust and engagement and intimacy. So those aspects are going to be very important over the next few years till we get to that AGI phase, right? And finally, if there is something that you want to start doing, if you haven't done already, I think some of you have, start consuming some valuable content. If you're spending a certain amount of time on a digital device, I would strongly recommend looking at what are the things happening in this AI world. Start consuming some podcasts, and Prabhat and his team will be very happy to share some of those good ones, the relevant, valuable ones. There's a lot of noise in the system. Don't get into that. Some very valuable ones I would highly recommend you guys to get into. And keep in mind, this is not just if you want to become a researcher or a software engineer. Even if you are a fine arts, a humanities inclined person, AI will touch your life. And start listening to this, to some of those, to see how you can reorient your priorities, how you can align with how those technologies are going to come out, right? And there are a bunch of online courses as well. I would very strongly recommend, but keep that for a little later. Start with the consumption aspect of it. Then you can worry about online courses and all of those things. But the key takeaway being, if whether or not you think you will be working on artificial intelligence or computers and code, you should dive into artificial intelligence today and start looking at how do things change, how does my world change, how do I make my life better. And remember, one of the things I touched upon in the beginning, there's a lot of doomsday predictions and fear mongering and on a lot of hype also in the space, but look at it from a pragmatic, practical standpoint. Look at how it will add value to you as an individual, how it will help amplify your skills, your creativity, your behaviors, so you can actually play a very integral, important role in that AGI-driven world. That's the message I had for you guys today. I know it's a lot to unpack in 1 hour. Hopefully, I've not made it too intense. We can always do follow-up sessions. So I'll pause now, guys, and it's probably a good time to hear from you. What do you think about it? Do you have any questions? Do you have any thoughts? Over to you.
I think you can raise your hand. Anybody who has a question or wants to make a comment, and then Prachi can moderate that. Yeah.
I think the best is to unmute yourself and just go for it.
Yeah.
I'm looking at chat also in case someone wants to put something there.
So may I?
Yes, please.
Yeah, so it's more of a recommendation that I want from you. I'm a student in second year of Manipal Institute of Technology. I'm studying AI itself, but they haven't started teaching us neural networks and all that. But I want to get started on it. So what would you recommend for me?
Right. Where are you studying? Where in Manipal?
Manipal.
At Manipal? At Manipal?
Manipal Institute of Technology.
Okay. So it's a slightly tricky thing, Aryan. Here's what I would recommend. Get your hands on the course. Okay.
Mm-hmm.
Get your hands on the course. See what is lined up in the next few months and semesters, etc. Look at when they are starting to introduce some of these concepts to you. I'm pretty sure some of it will be there at some point. I don't know when.
Yeah, actually, my next sem starts with AI. I'm in third sem right now, which is about to get over.
Okay, fair enough. So the next step is in third sem. What are the things that you're going to cover, right? Essentially, what I'm guiding you towards is don't go in a completely different direction than what your course material might be. You can always sort of do a little extra on the side, but don't deviate too much from it. I think Manipal is a very good institute. They would have figured out a bunch of things in terms of what needs to be taught to you. If you want a head start on it, by all means go ahead, but I would suggest align with that. So they probably will start with machine learning, then they will get into deep learning to some extent, then they will walk you get into the depths of ANN, artificial neural networks, then they will talk about the variants of neural networks, then they will get into the transformer architecture. So follow a similar path. If you want to stay ahead, by all means do that. So I think there are a lot of people putting out great content out there. However, if you are going to follow podcasts and material on YouTube or elsewhere, there are 7 or 8 great guys who produce terrific content, and these are the guys who actually did it themselves. So this is one of my golden rules, Aryan. If I'm listening to one of these podcasts on neural networks or on any of these technologies, I'd like to listen about it from the guys who actually did it. Okay. So there's a ton of things from there's this guy called Andrei Karpathy. He's got some very, very good course content. There's a bunch of things from Harvard. So there's it's a wild, wild west once you go looking out. So potentially one of the things that we could do, Prabhat, is for Aryan and the likes, we can give him some of our recommendations of what are the ones that you should look at to augment what you're going to learn in college. Don't deviate from that. I say it again because then you'll be lost in your class. Align to that, but then augment your knowledge and your whatever you're going to consume so you can stay one step ahead of the curve, right? That's by all means very fair. So I think we can do that for you and send some of those people who create great content on
That would,
it.
that would be
Fantastic.
fantastic. Thank you. Thank you.
What else? Anything else?
I think many of the students haven't spoken, right, and many of them have done something on AI. So anybody, please feel free, to ask.
There's Ane, there's Rishi.
Yeah. There's Anay Rishi, there is Vidyut, Soham. Don't feel shy. Just ask your questions.
Yeah, you can ask a question, or you can also tell me. See, I told you at the beginning, uh, you guys probably have scratched deeper than I've covered here. So if there's something that you've done more exciting, I think you should just try to summarize it in a quick minute or two. Very happy to hear.
Very minor question, small one. As you said also earlier, every industry, technology is developing at an exponential rate. And I wanted to know whether, in your opinion, it's smart to look at AI and learn more about it on a theoretical aspect rather than a practical one, since I'm not sure whether after a certain point, knowing the the coding behind it will be of any relevancy after a certain point.
So that depends on what are your interests, Vasud. If you are inclined towards getting into the technical aspects and following a career path in being one of those guys who will develop some of these technologies tools, will contribute to its growth, its building of it, I think you should dive into the technical bit of it, the theory to start with, and then get into the practical aspects of it, right? The good thing about many of these tools and technologies is they're open source. So everything is out there. Most things that Facebook does, so Facebook, other than having a social media network, they do a very good job of creating some of the best large language models out there, and they are few of the open source models. So you can download something called Llama on your machine, on your computer, and start looking at it right away. So that's when, if you are that's what you should do if you're looking at it from getting into the technical side of it. If you think you will pursue a career in some other space, then I think you should look at how the existence of such a tool or a technology can amplify your outcome and the impact that you can create. For example, if you're going to be a musician, right? How can you use your language, your knowledge of these of rhythm and chords and various technical aspects of music, and these technologies, and how can you create something better than just what a computer can create or just what a human being can create? I think that should be your approach. So you should dive into it either way. If you're not inclined towards the technical aspect, I wouldn't recommend getting into the code and the models and all of those networks. No, you just try to understand how the consumption of some of these things, and how you can use these as an enabler, as a transformative enabler to make you more impactful. I think that so you should choose that path and then decide how you go about it.
Vinod, we have Rishi with a question. Rishi,
Yes,
go
Rishi.
ahead.
Yeah, thank you. So I have a question about the neural networks which you mentioned, AI neural networks. So you said that based on the data we feed, it uses what do you say, the neural networks which are similar to our brain to compute this information and get an output. So my question is, if it uses similar, what do you say, networking processes which our brain use, what is the scope of it to surpass human ability if it uses the, what do you say, same type of networks which our brain uses?
Good question, Rishi. So look at it like this: like what is the uh, average lifespan of a human being in today's world, right? I'm going to be a little optimistic and say 100 years, right? So there's a certain amount of information you can consume in 100 years. So your knowledge will be limited to those 100 years of your existence. And as you grow older, you start forgetting a bunch of things that you'd learned early on, right? So the human brain is finite in terms of retention. both in terms of how much it can hold and how much it can retain. But that's where some of these computers are challenging that notion, and they are saying, so, for example, some of these large language models are being trained on all knowledge that exists from the beginning of time. Okay, so can you imagine how much information that must be?
Yeah.
That's a lot of information for a human brain to hold. And as a consequence, the decisions that will come out from a network of this kind, from an artificial intelligence or an AGI tool in the future, which is why they say it can be profoundly more impactful, bigger, larger than what a human can do. That is that single most factor. So think of it like this, right? Physicians, and I mean, I don't mean to say physicians are going anywhere. Physicians are going to be with us for forever. But there are some early tools that have been trained on medical literature, and when a doctor is diagnosing a patient, they have a certain set of knowledge that they have gained over the course of their 8-9 years of whatever they studied so hard during their college days. And then they've been always updating themselves with certain literature, medical literature, peer reviewed journals that come out from time to time. And that's the extent of their knowledge, right? And they tend to diagnose, treat patients based on that information. But there are hundreds of thousands of such new discoveries in the medical space being made every single day, and many of these come out as peer-reviewed journals. You can practically not expect a human physician to be reading all of these and reading it in real time to be able to facilitate the treatment of a patient, right? And that's what some of these machines can do, some of these tools can do. So they are able to consume this information very fast. They are able to hold it in their memory. They're able to synthesize it, and they're able to come out with a treatment option with the human in the loop. The medical doctor is always going to be there, but they're going to bounce it out the medical doctor and say, hey, I found this information. Do you think this might be relevant? And this is not humanly physical for just a doctor to be doing without a tool like this. So that's the reason they're saying we don't stop at those 86 billion neurons. We go even beyond that, and we surpass these capabilities, and we do a lot more. And one of the things I didn't touch upon is the human progress, right? I mean, there are a lot of philosophical things that are being discussed, and people are talking about a similar graph like this exponentiality graph. The human progress, many people are saying, and I think there is a lot of truth in that. The human progress is also going to follow a similar path like this. We are at the phase where some of these things are starting to change, but we could soon be in a post-labor economic scenario where a lot of these tools and technologies and machines do so much for us that the overall economic output is amplified several times over. I know it sounds like science fiction, but trust me, 10 years from now, we're going to see some of these happen, guys, right? I mean, it is inevitable. In 10 years from now, we might be in that post-labor economic world where you might reach a utopian scenario of everybody's rich, everybody has a lot of money because these tools are doing so much, creating so much economic output. We are such an advanced civilization, and that is very real. As a matter of fact, when you ask many of the people behind this research to predict what they see beyond 5 years, many of them will not do it, because most people cannot see what is beyond 5 years. That world is too good to be true. On the flip side, it can be very dangerous too, but let's leave it for another day. But if you look at the glass half full model, the optimistic version of it, we will be in a world that will be a utopian scenario. We will be living a lovely world where we won't have to worry about where the next paycheck is going to come from. A lot of people say this, right? You will work because you want to work, right? Not because you need to work. People will work as a hobby. those kind of beautiful scenarios are being painted, but we won't get distracted with some of those things here. But the notion, Rishi, is that if these machines can be much more larger, bigger, more scalable than what the human mind is capable of, the output that we can expect in a society, in a country, for humankind can be much more than what is being done today. The amplification factor is just massively great.
Thanks. No, thanks so much for giving all the answers in such elaborate detail. And we are close to 7:30 now, so my aim is not to preempt you into closing this lecture, but I'd request you to please stop sharing your window so that we can take a quick screenshot and of our Prabhat. Can you please do that for us?
Yeah, sure. I
Yeah,
think everyone can switch on their video. So
yeah. Anay, Rishi, and Ankita, and Shishadri Krishnan, I think. Is that Shreya?
yeah.
Yeah, so Shreya, if you can turn on your screen, Ankita.
Okay.
So we're going to be flexing this on our LinkedIn profile, Vinod, just for your information. And we'll be
by
tagging
all
you there.
means. Yeah.
Okay.
Yes. So now everyone's on. Prabhat, I think now is a good time.
So 3, 2, 1.
Looks like a very animated session rather than being a very serious one, especially for people as uninitiated as me, Vinod. I was taking down all these notes, while you were speaking, so that I can tell my children that I'm a bit literate on what AI is all about. So in terms of the depth that you've gone into, I won't say that it was all what's the word for it? It's all German to me. It's all French to me. What's the phrase? I'm forgetting that. But definitely I could grab some bites out of it. I was very happy to see that Vasud was really participative and he asked some very insightful questions. And when I look at kids like you, it really, I mean, it's so heartening to see how far ahead you all are as far as technology is concerned. Thank you, Rishi. I wish Saivid, I mean, I hope Saividya that you've gained a lot out of it. Soham would already be knowing a lot. And some of us, have left the meeting. There were quite a few of us. We were 19 to start with, Vinod. And I hope, Aryan, that this, particularly for you, because you've been doing this AI thing, that this has been really informative for you. Shreya, you joined us late, but I'm hoping that you could glean a whole lot out of it. So, Vinod, I mean, I'm not the expert who can make a comment on what you just said, but in my capacity, I would say that you've been able to brush off some of your intelligence onto me, so that I can quote some words like machine learning and deep learning, and if I fold a paper so many times. So I would be taking those creative and artistic aspects of your of your presentation with me. Aryan would, of course, be taking the tip that you told him about, concentrating, focusing on his academics at present and where the course is taking him, and do something to supplement it. Vasud, I don't know whether you are taking from Vasud or Vasud is taking from you. So I think both of you seemed
It's
equally.
mutual. I think it's mutual.
Yes,
With
yes.
everyone, with all of
And
them.
thank you so much for your humility, because what you are talking about is really recondite. It's really esoteric. And I, for one, was not unnerved in listening to you. I mean, I didn't get the shutters down that I'm a non-techie. So thank you for all your humility. Thank you for the connection that you made with all of us at a level where it doesn't intimidate us. And at the more technical level, I think I will leave it to Prabhat to express our gratitude. I know your time is very precious. Prabhat, I'd leave you to sort of sum this up in terms of the technicalities of what Vinod has presented on a more romanticized and on a more literary note. I would just say thank you for your presence. It has been a very, very well spent 1.5 hours with you. Prabhat.
Yeah.
Thank you,
So
Prachi.
thank you so much, Vinod. Thank you for taking the time out. And I think, as I said in the beginning, this is one of the most important subjects, and it touches everybody in some form or the other. I mean, I would look at it as, on one hand, it touches people who want to pursue a career in computer science. It directly impacts them. And then even people who are not pursuing a career in computer science and something else is going to impact them. And at this point, it's better to first understand AI and the building blocks, the challenges, etc., and keep building on it. And I really liked your advice on the podcast, right? At this point of time, there's just too much of information. You can easily get lost. So if you can share some of those links, it'll be easy for the kids to navigate. So thanks, Vinod. Thank you so much for your time. And for all of you, in case you guys have any questions that you want to share with Vinod, I'm sure, you could send it to us and we'll forward it to Vinod. And if you want to share your paper and take an opinion, I mean, you can always approach Vinod now, depending on his time and based on his availability, he's going to respond. Because about 5 or 6 kids in this class, they're all writing papers on AI. And
Right.
yeah, it'll be nice to get your perspectives and views.
It's very exciting. I think, just hearing some of the questions that uh, these students have asked, and the fact that some of them are writing papers, I think that's the way forward. Just dive into it, because
Yeah.
I don't think any of us can take a position to say I'm going to be insulated and I'm going to operate in my own little island. It's going to touch our lives. And I know I've said some pretty radical things like post-labor economic world and utopia and all of those things. Uh, the reason I used those terms was to provoke you guys to some extent, right? I want to set you thinking. I don't want you to go back and say, hey, ho gaya, band karo. I want you to go and keep researching this and see what's coming and how do I brace for impact, right? I mean, that's not the best phrase, but how do I prepare myself for it? So it's basically put your thinking hats on, start looking at the different dimensions of this. Some of the students like Aryan are a little further ahead compared to the others, but I think there's a lot of enthusiasm and excitement from some of the people I've seen here. So all the best, guys, and I really wish you the best. Keep rocking, and you can always reach out to me through Prachi or Prabhat if you want to bounce off something or just want me to be your soundboard. And a lot of gratitude, Prachi. Those were very kind words. Thank you, Prabhat. Always great to be surrounded by youngsters. The reason I didn't even hesitate to take this up is because as I said, I love to be surrounded by young people. They're always challenging me. They're always inspiring me. So
Yeah. No,
great.
absolutely. And you have another familiar face, Tanvi.
I saw Tanvi. She just pinged. Hey, Tanvi. Where's
And
Tanvi?
thank you so much, all of you, Vasud, Sai Vidyut, Aryan, Ankit.